let's just kind of review trig a little bit today. That's it. That's all we're going to do. And then if we get some time, we'll hit up some homework questions. All right, so first of all, if you don't have one from last year that you brought with you, like today Roxanne brought hers, you all have one stuff that your teachers gave you last year, you can bring it, but you gotta look at those things as crutches that you kind of need to heal beyond and get away from them, because we can't use them on the test. So you guys have got to remember this stuff. But first of all, I want you guys to be aware that in calculus, we only do radians, okay? So degrees, we don't do degrees. So we'll never use those again in here, okay? We're only doing radians. There's your unit circle. Did we talk about the gang signs yesterday? Okay, so that's really helpful for knowing your x and y values, right? But the radians are just kind of a pain in the butt that you got to know. Okay. So there's that. Now something that I don't think most teachers have their students memorize, but I'm going to really encourage you guys to memorize those, is your tangent values. So on your notes for today, let's go ahead and write this down. This is going to make life a lot easier if you have your tangent values memorized as well. I was going to try to work around that, but it's pretty difficult to work around it, honestly. Kind of need to know them. So let's make a unit circle. And let's go ahead and put our radians on there. We have 0, pi over 6, etc. I'll put them all up here. You guys can copy them. Four, pi over, bless you, 3, I believe. You guys can check me. I'm just going from memory here, but I'm pretty sure these are all right. So those are all the radians, right? But what you want to know is you want to know the tangent values that go with all of these. So tangent is it's y divided by x, right? We talked about that yesterday, but trying to figure that out in the set of a problem is a little bit complicated. So let's see what they are. First of all, for all the pi over 4s, it's always 1, but some of them are negative. So like this tangent value is 1. I'm going to make some space here. This tangent value is 1. This tangent value is 1. So is this one. But some of them are negative. Now the ones that are negative, remember we're doing y divided by x, right? So if they're both positive, then what's the outcome going to be? Positive. So when you're in this quadrant, x is positive and y is positive. So that's positive. Now over here, x is negative, but y is positive. So what will the tangent be? Negative. Over here, the x and the y are both negative. So what happens when you divide two negatives? That's a positive. Over here, what do you think this is going to be? So the ones right in the middle there are 1. Okay. Something else is here. At these two spots, what's the y value? 0. So if you have 0 over anything, what's it going to be? So here the tangent values are 0. Right? Now here, what's the x value? 0 again, but it's y over x. So what happens when you have 0, x is on the bottom, right? So what happens when you have 0 on the bottom? It's undefined here, so we'll want to write that. Undefined and undefined. Okay. Now, I'm not going to figure out the other two. I just have them memorized, and I would say that's what you want to do too, okay? It's pretty simple. So the ones that are closer to the x-axis, like this point and this point, they're radical 3 over 3. Okay? Radical 3 over 3. But remember, it's x over y, right? So the same rule about the signs applies. This one will be what? Positive or negative? And this one will be negative, okay? That looks like it's minus. It's not. It's just negative. I don't want you to think that's 11 pi over 6 minus radical 3 over 3. This is the radian, and this is the tangent value. All right, and the same thing applies over here. These two are closer to the x-axis, right? So those ones are radical 3 over 3s as well. Which one's positive or negative? Which one's the, let me rephrase that. Which one's the negative one? The top one, right? All right. Now, as for the two spots that are closer to the y-axis, those tangent values are just square root of 3. No bottom, just square root of 3. So it's this. All of those are square root of 3, and that's it. But the signs apply, right? Is that what you were going to ask? What was your question? Yeah.
Sorry.
Bless you. All right. So positive or negative?
Positive. Negative. Positive. Negative.
There you go. So there's your tangent values. You're going to want to know those. Those are nice. Those are nice to know. Okay. So having said that, let me throw a couple of just random problems at you guys, and we'll practice today. So today, go ahead, use your cheat sheets. If you don't have a unit circle on hand, you might want to Google one and bring it up. I'll pull mine up too every once in a while, but you're going to want to probably look somewhere. Just practice today, get you guys really used to finding all these things. Okay. So, what else do we need to know? We wrote this yesterday, right? Cosine gives you the what value? X value. And sine gives you the y value. Okay. We also talked about how secant is the reciprocal of cosine, right? And cosecant is the reciprocal of sine. Now here's something that's a little bit different that I don't think I told you yesterday, but I'll tell you now. Cotangent is the reciprocal of, well, that's true. Tangent is, or cotangent is cosine over sine, that's true. But it's also the reciprocal of tangent, okay? So that's a new thing. I didn't tell you that yesterday. And the reason I didn't tell you yesterday is because I was trying to work around you guys not knowing the tangent values and see if you figure it out without that. But it's just too much. You kind of need to know those tangent values. It makes life like way easier if you know those. So those are some other facts that you'll want to keep in mind. So let's go ahead and I'm going to throw a couple of problems at you guys here. Can I change slides? Not yet? Yeah. All right, so here we go. Let's do some practice here. So how about tangent of 2 pi over 3? Okay, so how do you do this? Well, you look at the angle, right? And this is a tangent value, right? So we just wrote down all of our tangent values. So we're going to go back to our tangent graph now. We're going to find where 2 pi over 3 is. Do you guys see it? And what's the tangent value?
Negative radical 3.
Just negative radical 3. You could do the y value over the x if you want to, but this is much easier. This is the answer if you did that and simplified it. So we're just gonna say negative radical 3. So let me throw one at you guys now. How about give me tangent of 3 pi over 2? Go for it. I'm going to call on you in just a second. Look at what you wrote. You have it?
No, how did you get negative radicals?
So it's tangent, right? which tells me I'm looking at this picture. Now, I find that angle. Oops, I missed it. Go back. There it is. There's the answer. Okay, so here we go. I'm going to ask Chris, what'd you get? Huh? Undefined. It doesn't exist. There's no solution there. All right, let's do another one. Sine of 5 pi over 4. Sine of 5 pi over 4. Yes, sir? You have the answer? Okay, go for it. No, no. No. Wait, no, wait. It is. Yay, you guys knew I was ridiculous. That's good. That means you know what's going on. So let's see why, though. Because sine is what value? This is the y value, right? And what angle am I at? I'm at 5 pi over 4. So now I'm going to go, am I going to go to my tangent circle for this one? No, right? We're going to go to the regular unit circle for this one. So let's back up and let's find where the angle was. The angle was 5 pi over 4, right? Now we look for the y value, and there it is, right? Let's do another one. So you're right, Ryan. Radical 2 over 2. All right. So how about sine of 11 pi over 6? I want to make sure that people get a chance. I'm gonna use my cards actually, but I will get you a point for the last one. And Brody too. Okay, so I'm gonna ask Juliana. What'd you get? Huh? Oh, are you looking at degrees? Yes. There you go, -1/2. All right. Okay, now this one, I'm going to let you guys do this one too. But before you do, I'm going to ask a question. Cosine, Brandon, cosine tells us the what value? The x value. So go ahead and find it for me. Give me the answer there. Cosine of 5 pi over 2. See if you can find. I'll give you like a few seconds. 5. Did I say 2?
Yeah.
4. Sorry.
Sorry.
There's an answer for that. Jacob, what'd you get? Oh, yes. He's right. Now, how about this one? Same thing, x value, right? What do you think, Nikaya? Uh-huh. True. You're confused. So you found the angle, right?
Yes.
And cosine is the what value? So what's the x coordinate for that angle? You're right. All right, let's do another one. Okay, find that one. Pearl, you with us? Okay. Just making sure because I got your card. Hey, what's up, Ryan? Oh. I'm going to use my cards first. All right, Pearl, what is it? Okay. So it's tangent, right? So I'm going to use my tangent circle, and we're going to find where 7 pi over 6 is at, right? Do you see it? And what's the tangent value that we put there? What is it? Is it positive? All right. Okay. So that's evaluating, just plugging numbers in. But we're gonna have to I don't have a lot of time, so I'm gonna have to take it up a notch here. Yeah.
So if it's like cosine and then a number, you're looking for the x, and then the sine you're looking for the y.
That's correct. And then for the tangent, you're using a whole other circle. So we got that. If it's sine, you're looking for y. If it's cosine, you're looking for x. If it's tangent, use that whole other circle. It's not x or y. It's like a fraction of the two, but we don't need to worry about that. All right, now I'm going to take it up a notch. Ready?
Oh my God, how many notches is there?
Oh, there's a lot of notches. There's a lot of notches. All right, secant of, how about, okay, so for these, now okay, I want you guys to repeat this after me, right? We like sine, cosine, and tangent. Okay, let's say it again all at once. We like sine, cosine, and tangent. We don't like. So we're going to fix that. Yes.
Nothing. Go.
Wouldn't it just be 1 over x?
That's true. That's true. All right, so let's do this. So we don't like secant, right? So what does secant equal though?
1 over x.
So I'm going to write this. So anytime you have secant, cosecant, or cotangent, we're going to change it. But after you change it, we have a little bit of work to do. So let's do this. What's cosine of 5 pi over 6? Negative radical 3 over 2. I agree. I agree. I'm going to put evaluate for evaluate, right? Now, what's next? The next thing I'm going to say is, let's simplify this. So what do we do about the little 2 on the bottom? How do I get rid of it? And so that's going to give me what? And we still need to simplify it because we don't like. And so that gives me negative 2 radical 3 over 3. Okay? So let me throw in at you guys. Cosecant of pi over 6. Okay, I'll walk it. I'm going to ask Roxanne, what'd you get?
2.
2 is right. Because cosecant is 1 over sine, right? And sine of pi over 6 is a half. Multiply the top and bottom by 2. You get 2. All right? Let me throw another one at you, and then after that, guess what we're doing? We're taking it up a notch.
Wait, can I get the other one first?
This one? I'll leave it for you. All right, cotangent of
Cotangent.
Okay. Let me ask a question here. Isaac, do I like cotangent? We don't like cotangent. So we need to change cotangent, right? What are we going to change cotangent to? 1 over tangent, right? I'm going to ask Jade what she got. What'd you get? Say it. 3 over 4 pi. No. But we'll get there. What was your question, Manny?
I was gonna say, why do you, like the previous one, why do you multiply times 2?
Well, it's a complex fraction. It's a fraction inside of a fraction. So you multiply by the little number in the bottom there to simplify it. All right, so we are going to do a reciprocal, though. You're right in that case, Jade. But first, the first thing that we're going to do, Angelique says, I'm going to change cotangent into what? What? Cool. I'm not going to flip the 4 pi over 3 over, but I am going to do that, okay? Now, the next thing I'm going to ask Alyssa, what's tangent of 4 pi over 3? Cool. And then I'm going to ask Brody what else needs to be done.
For that one, yeah, we don't like radicals on the bottom.
So we do what?
We can put it on the top as a negative radical.
That's true, but we're going to deal with it in another way.
Multiply the top and bottom.
There's our final answer right there. Okay. Okay, we're going to transition here, though. I'm getting away from this, and I wish I had more time spent on it, because I do feel like it gives me more practice. I really can't do, this was like too much anyway, but I can't give you another day, so, you know, come see me after school or something if you're having trouble still. But I do have to keep going. We're going to talk about arc functions here a little bit. So, it is. So you guys know how sine of theta equals y, right? Well, the inverse of sine is arc sine. And an inverse function makes the input become an output and the output become an input. So in this case, my input was theta, so now that's going to be my output. My output over here is y, so now that's going to be my input. Okay? Same thing applies to cosine. If cosine of theta equals y, then arc cosine, well, I guess I should say x in this case, huh? Then arc cosine, that's a little -1, theta. And so on and so forth. Tangent of theta gives you a, then arc tangent of a gives you theta. I'm going to say a, just because I don't want to write y over x, but you could. And so on. I'm just going to write them all up here at this point. It's kind of repetitive, honestly, but I think we have the point at this point. So that's the arc functions. Next class, we're going to, not tomorrow, because tomorrow's our quiz, but next class, we're going to be finding the derivatives of those guys over there. But once again, trust me, it's much easier than what we're doing today. You have a question? Oh, it would be x over y. But cotangent is 1 over tangent. But the arc functions, transforming them, I'll show you how to deal with those. So we're going to do an example. All right, so on Thursday, you guys are going to be seeing some questions like this. Okay? So let's go ahead and write this one down. All right, so now on these, you plug in something, but what does it always give you every time? Theta. In other words, it's going to give you the angle. So our answer this time is going to be an angle. See, in the last examples I gave you the angle and you found me the coordinate. But now I'm giving you the coordinate and you're going to find the angle. It's the opposite. So the first thing I like to do then is I like to rewrite this. I don't like the inverse functions. I like the normal ones. So instead of arc sine of a half equals theta, I'm going to put sine of theta equals, what do you think? Yeah, I like to flip them around. So now I know I'm going to look at my unit circle for what value? True, but the y value, because this is sine. So I'm going to look for what y value is a half. So look on your unit circle and find for me where your y value is equal to half.
The negative exponent, like, does it disappear because you flip it?
Yeah. So what is it? Pi over 6. Okay, now there's also another one Andy saw, right? It was 5 pi over 6. We're not gonna use that one. But I just want you guys to get familiar with that process for now, and then I'll tell you why we're not using that in a second. Okay? So let's do this one. Cosine inverse of negative radical 2 over 2. Okay? So what am I going to write first? Okay? So now I'm looking for what kind of a value? An x value of negative radical 2 over 2. Can you guys find that on your unit circle? Pi over 4? No, not quite. You're close. 3 pi over 4 works. And that's the answer. So we're looking for the angle this time. Okay? Now there's another answer, right? There is another answer, but I'm not going to use it, and I'll tell you why in a minute. So for now, so long as you can find one, I'm happy. All right, let me throw another one at you here. How about arctan of 1? I want you guys to see if you can figure out what arctan of 1 would be. Okay, now we got a real fun one coming up. You ready? How about this? Arcsecant of 2. I want to find out what arcsecant of 2 is. So you guys can just tell me what to do here. What am I going to do? Make it equal theta. And then I'm going to write do we like secant? This is what's different, right? We've got to fix it. I'm going to change secant into what? Do I like 1 over cosine?
Yes.
I like cosine better, but I would sure like to have just cosine and not 1 over cosine. So here's where it gets a little bit different. What can I do to fix this? That's hard. You could. How about we just flip it? If I flip this side, what do I have to do over there? What do you guys think? Okay, so now I want to find a what value? An x value that equals a half. Can you guys do that? What is it? Pi over 3 is good. I heard someone say pi over 6. You're looking at the y value. Pi over 3. Okay, I'm going to throw one at you. Ready? I want you guys to do cosecant of radical 2. Okay, for reasons that I'm not going to go into right now, just because we don't have time, but I will say that for the arc functions, well, I guess I'll give you a little bit of reason. You guys remember how a function is only a function if when you plug a number in, you get one answer out, right? Well, the problem is that this isn't a function if you get two answers. So what they did was they restricted to what part of the circle you're allowed to pull answers from. So that way, every time you plug in a number, you get only one answer out. Okay? So now this is something you guys want to write down in your notes. Okay? Ready? We're going to title this Range Restrictions for arc trig functions. I love that vocabulary. Now, this is one of those great things for when your parents are in the, what'd you learn today? And you could say, we learned range restrictions for arc trig functions. And they'll be like, oh yeah, I remember that. I'm just kidding. I use that every day, just last night when I was cooking. All right. Here we go. So, we're going to draw two circles. We're going to put sine, arc sine. We're going to put arc cosecant. And we're going to put arc tangent over here on above this circle. And on this circle over here, we're going to put cosine, arc secant, and arc cotangent. I'm going to show you what part of the circle you're allowed to pull answers from for each of these sets. For cosine, arc secant, and arc cotangent, you're only allowed to pull from, drum roll please, answers up there. That's it. You're only allowed to pull answers from the top of your unit circle. So like, for instance, give me an arc, one of these that we did earlier. Did we do arc secant or arc cosine? That's one of our examples. What did we do?
I think we did. Oh, that was 10 of 1.
Arc tangent? We'll get to that
Arc
one.
tangent.
So we didn't do an arc of these.
We did an arc of secant.
We did?
Yeah.
What did we get for our answer?
Pi over 3.
Okay, that's right here, right? There's another place where that same angle would give you a similar output, and it's down here, but we would not pull that one. You only take from the top of your circle. Okay, now for these guys over here, you're only allowed to pull, you think so, but no. You're only allowed to pull, very good. How'd you know that?
I guess because sine.
You're only allowed to pull from over here, but
Sine has to walk directly one on the right, one on the left.
you got it. Nice job, Marcos. That's right. Perfect. You're only allowed to pull from the right, but there's a little bit of a twist with these ones. You ready? Let's put some numbers up here. This is pi over
6,
pi over, and pi over, and this is pi over 2, right? Okay. You can pull answers from down here also, but guess what? It's not the ones that are on your unit circle. It's the negative ones. So what's this? If this is pi over 6, this is negative pi over 6. This is, and this is, okay, so that's supposed to be a 2. So in other words, when you're dealing with arc sine, arc cosecant, or arc tangent, your answers could be any one of these. I understand that this is 11 pi over 6 on your unit circle, but we're not going to call it that when you're doing arc functions. We're going to call it negative pi over 6. Yeah.
So it's the bottom left quadrant doesn't exist.
This guy? Yeah, so arc sine, these guys are not defined over here. We don't pull answers from that for arc functions. And the reason for that is because if we did, you would get 2 answers for 1 input, and when that happens, it's not technically a function anymore. So all the neat little rules that we have about functions wouldn't apply if we allowed it to be extended there. So what time are we looking at? 42? All right. I want to do one quick example for you. I'm just going to do it, and then I want to spend some time on homework with you guys. Okay? So here we go. Let's say I gave you guys this. Arc sine of negative radical 3 over 2, right? So, I'm going to rewrite that like this, correct? You good? Then I'm going to look at my unit circle. Can you guys find on your unit circle where a y value has negative radical 3 over 2? Give me both answers. There are two, but just give me both.
5 pi over 3.
Okay, that's one. Give me another one. I agree. Which one of these, though? Where is arc sine? Where do we pull answers for arc sine? On the right side. Which one of these am I going to use? We're going to use 5 pi over 3, but I'm not going to call it 5 pi over 3. We can't even use this one because it comes from the right side of the circle, right? I'm going to call this negative pi over 3, though. That's your answer. Back up. So it's here, right? And yes, that is 5 pi over 3, but we're not going to call it 5 pi over 3. We're going to call it negative pi over 3. Okay? So that's your trig review for the day. I'll throw some homework at you so you can practice some more. I'll upload the video in case you guys want to see more of my excellent teaching. Honestly, this was a lot to try to cram in, but you know, we can only do so much. I heard a lot of questions about number 12 on the homework. So let's look at number 12. Number 12 is really tough. Number 12, if anybody actually figured that out on their own, I expect everybody to try it, so I should see something and you get full credit. But if anybody actually figured that out on their own, you probably don't need me to teach you anything anymore. It's just a tough question. It really is. Let's see. 1.7. And what did you say about what?
What?
Were you saying something?
I said it was really easy. It took me like a minute.
So let's go ahead and work on number 12 together. If we have time, we'll do another one, but I doubt we'll have time. Are you guys ready? For what values of x does the tangent line of the curve y equals x squared plus 5 intersect the y-axis at 0? Now, somebody came up there and showed me the picture. If you even drew the picture, that's awesome. Because I said, hint, a good way to get started would be to sketch the picture. So, x squared plus 5 would look something like that, right? And the point 0,4 is down here. Now, we're looking for tangent lines that go through that dot but hit our curve, right? So can you guys imagine what that would look like? Maybe something like that and that, right? There's two answers. Okay. Now, they want to know for what value of x. So I'm looking for x, right? Okay. Ugh. Now, what do we know about tangent lines? They give you the instantaneous rate of change. So let's see. What's the derivative of this then? If I want to find the instantaneous rate of change of this, right? So what's y prime? 2x. So that's my slope, right? But do I know what x value it's touching at? I don't. So I can't really plug a number in, right? What else can we do here? We do know it goes through this point. So I wonder if we could use our point slope formula. What's the y value that they gave me? -4. I wonder if this will work.
It would be like 0.
Okay. And what's the slope? 2x. And what's the x value?
0. It would be like 2x.
You guys good? Right? How does that help? Well, what did I just find? Well, no, I found the tangent line equation, right? But why? It's a square, right? It shouldn't be a square. But it's like that because we don't know the slope, and there's two of them, right? So here's what we're gonna do. What else does the tangent line do to this graph? It starts with a T. It's a very simple word. It touches it. And when two graphs touch, what do we know about those two equations at that point? They're equal to each other. So the point where they're touching is where x squared plus 5 is equal to what? Yeah. If anybody figured that out, you'd be like a math god, just so you know. Don't feel bad.
No, that's actually easy. Whoa, that's crazy.
Yeah, if you figured, I mean, wow. Guys, x is equal to what?
Plus or minus 3.
Yes, and doesn't that make sense?
Yeah.
No, not the whole process, but I mean the answer. The fact that you get two answers, that makes sense based on our picture, right? So that's a really crazy question. It was actually in our textbook, and I thought, yeah, let's torture them a little bit. That question is even hard by AP standards. Like that's a stupid question. But it's fun. We'll play with it. Okay? Every year I look at this, it makes me think. Like I wasn't pretending. When you guys saw me up here pausing, I was like, I had to think.
Yeah,
I wasn't joking. I was really serious. I was like, yeah, it's a hard question. All right, so there's that. We have 3 minutes. Anything else? The graph of f of x is tangent x given below. Find f prime of pi over 2. Well, so f prime is what? Derivative of tangent, which is? There you go. And we're plugging in pi over 2, right? Now, secant of pi over 2, that's 1 over cosine of pi over 2, isn't it? What's cosine of pi over 2? You guys are all counting.
Oh, shoot.
it's 1/2.
It's 0.
Yeah.
What's 1 over 0? It's undefined. Now, find f prime of pi over 2. We get an undefined slope there. Then use the graph to explain your answer. Well, here's pi over 2. What do you guys notice about that line? That's a no-touch zone. There can't be a slope there because the graph doesn't exist there, and that's why the slope is undefined. Okay? That's probably all we have time for. So go ahead and pass your homework forward, and we're going to call it a day.